What is locus? In my last video, part 1, we have understood what locus is, and now we come to the constructions based on loci. Watch this video till the end. You might just learn how to get full marks in your constructions. So, like, share, comment and subscribe to my channel. Is there anyone who loves locus constructions? If you don't and you want to, then follow the simple tips shown in the video and you will get your full marks in such questions, which are of 3 to 4 marks in section B. So now let us look at our first construction from ICSE 2017 paper. Question 6a. Using a ruler and compass, construct triangle ABC in which AB is 7 cm, angle CAB is 60 degrees and AC is 5 cm, and construct the locus of points equidistant from AB and AC, and number 2, points equidistant from BA and BC. Hence, construct a circle touching the 3 sides of the triangle internally. So in order to solve this question, we should take one of the sides as the base. I can take AB 7 cm as the base, and then angle CAB I can construct 60 degrees and then AC as 5 cm. Let's see how we do it. So let us start with AB. This is 7 centimeters. We shall call this as AB. Then we have to construct 60 degrees CAB, that is angle A. That is our 60 degrees. Make sure that the arcs are kept short and the joining of points has to be exact. Now your angle CAB is already constructed. Now AC is 5 centimeters. So we take AC 5 centimeters. We keep the point of compass on A. There. That is how we get our point C. Then we join BC. And so our triangle is complete. This is our 60 degrees. This is 5 centimeter. Now we look at our question. Now we have to construct the locus of points equidistant from AB and AC. The common vertex is A here. And points equidistant from BA and BC, the common vertex is B here. So I have written just that over here. Now AB and AC, common vertex is A here. And AB is here, AC is here. So the point equidistant from AC and AB will be somewhere here. That will be angular bisector as we saw in my earlier video. The link will be in the description box. So we will write here the points equidistant from AB and AC will be the angular bisector of angle A means angle CAB. And here points equidistant from BA and BC, BA and BC will be somewhere here like this, the locus of the point. That will be again angular bisector, but now it will be angular bisector of angle B means it will be angular bisector of angle ABC. So we will say that is angular bisector of angle ABC. And that is what we'll have to do. So we will take the compass and we will bisect the two angles. Okay, so let us see how we do that. Now for angle CAB, we already have this arc. So we will take the radius more than half of this arc, like so, and we will draw the two arcs like this. They should be intersecting arc. And now let us join point A and this point of intersection. Now we have to be very careful because we have to draw the incircle at the end of it. So we take exactly the point of intersection. There. Now that becomes our angular bisector of angle CAB. Now let us do the same for angle B. So for angle B, let us keep the point of compass on B and draw the arc like so. And then take the radius more than half of that arc and draw the intersecting arc like so. Now again, we'll have to be very careful. Take exactly point B and the point of intersection here. Now where the two intersect, I will call that as point I. This is the point of intersection I. Okay, we have to construct the circle touching the three sides of the triangle internally, which means the circle should go like this. It should touch the sides of the triangle internally. And for that, we will have to have the radius of the incircle. Radius of the incircle will be from here to here. But now we'll have to show the perpendicular from I up to AB. So we will take the radius a little more than this much distance, and we shall draw one arc here and one arc here. Now we are going to use these 2 points over here, and we are going to take the radius more than half of it like so, and draw the arc which will intersect this earlier arc like so. Now we have to take this point I and this point of intersection, and we will show a dotted line. Let us say this point is P. Now from I to P is the radius of the incircle. So we will take the radius from I to P. We need to draw a circle. Be very careful. There. Now you can see there is a slight gap over here, this one, but that's still okay. So that finishes our construction. So now we have constructed the incircle, and with this type of diagram you can get your full mark. Now remember, constructing the incircle is a little difficult. I also had to do twice. The first time I did this, there was slight error. I had little gap over here, and here it was overlapping and going across like this. So I had to reconstruct these angular bisectors. So be very careful when you are drawing the angular bisectors, and then take exactly the same radius and make sure that the point of compass stays exactly here, and then you can draw the circle which will touch all the sides of the triangle. That completes our construction. Our second question is from 2019, question number 8C. Using ruler and compass only, construct a semicircle with diameter BC 7 cm. Locate a point A on the circumference of the semicircle such that A is equidistant from B and C. A is equidistant from B and C. So if a point is equidistant from two fixed points, remember in our earlier video we said that its locus is the perpendicular bisector of line segment joining the two fixed points. So A is going to lie on the perpendicular bisector of BC. Complete the cyclic quadrilateral ABCD such that D is equidistant from AB and BC. Now when a point is equidistant from two sides which meet at a point, then this D lies on the angular bisector of this angle B. We have done that in our what is locus part 1. Okay, so now that we understood that D is going to be equidistant from AB and BC, which means D lies on the angular bisector of angle B, then we have to measure angle ADC and write it down. Now for convenience sake, I have already drawn this diagram and I have written the facts. BC was the diameter 7 cm. So we draw BC, which is 7 cm. And A is equidistant from B and C. And so, according to our locus concept, A lies on the perpendicular bisector of BC. And so, B and C, we take these 2 points, put the point of compass, draw this arc here, draw this arc here, keep the same radius and point of compass here, draw this arc, and join this up. And then, that gives you the locus of point A. Now we come to D. D is equidistant from AB and BC. Where is AB? Here. BC is here. Now AB and BC make an angle with each other. So the locus of D will be the angular bisector of angle ABC. So we keep the point of compass here, draw this arc, then take this point and draw these intersecting arcs. Take this point of intersection and produce this till it cuts the semicircle. That will be our point D, because we have to complete the cyclic quadrilateral ABCD. So we'll join CD and DA to give us cyclic quadrilateral. And now they are asking us to find angle ADC. So we use the protractor and we measure angle ADC as 135 degrees. And that is our construction. This construction was 4 marks. So now you know how to get your 4 marks full. Our next question is from 2018 ICSE Board paper, and that is question 8C. Using ruler and compass only, construct triangle ABC such that BC is 5 cm, AB equal to 6.5 cm, and angle ABC is 120 degrees. Construct a circumcircle of triangle ABC and construct a cyclic quadrilateral ABCD such that D is equidistant from AB and BC. Now I'm going to draw this BC first, then I'm going to make angle 120, then I'm going to draw AB 6.5 cm, then I'm going to construct the circumcircle of triangle ABC, which will be obtained by bisecting any 2 sides of it. Okay, so let us see how we do this. So we start off by drawing BC. BC is 5. centimeter. And now we have to construct ABC as 120. So we will we'll draw an arc like so. Then keep the point of compass here. Draw one arc to make 60 degrees. Then use this point and draw another arc that is 120 degrees. And so we have now there. What we have is 120 degrees here. That's the angle. And now we have to take AB equal to 6.5. So 6.5 this is your 6.5. Let's check once again. Yeah, 6.5. So from B we will take like so. Can you see that arc over here? Let me just make it a little darker. Okay, that is our point E. And now we have to take point A and C and join it up to get our triangle ABC. Now we have to construct the circumcircle to this. So I have shown the bisectors of side BC and AC. As you can see, from A and C, I have taken these two arcs and these two arcs and joined these together. From B and C, I've taken these two arcs here and these two arcs here. Can you see over here? And then join them up. And then I have taken AO as the radius. See there? I've taken the center of the circle as O, and I have drawn the circle which is the circumcircle of this triangle ABC. Okay? Now, this was just to save on time, and now we have to come to the last step of this question, where they say that you complete ABCD cyclic quadrilateral where D is equidistant from AB and BC. Now you remember in the locus part 1, we talked about the point which is equidistant from two intersecting lines will be the angular bisector of the angle made by the two lines. And so if D is equidistant from AB and BC, the angle made by the two lines is angle ABC. So we need to bisect that. So we will do just that. So now we already have the angle 120. This arc is already there for us. So we will take the radius more than half and we will draw the arcs which will intersect each other like so. And now we will take point B and this point of intersection. Can you see this one? Yes. Okay, this one and B we will be joining very carefully, and there where it cuts the circle, that is our point D. Now this point D is equidistant from AB and BC. Okay, now let us see how we get the cyclic quadrilateral. We have to join C and D. And then D and A. So ABCD is our required cyclic quadrilateral, and that would give you your full marks 4 marks for this construction. Now we come to the last question of this video. This is 2016 question 11B. Use ruler and compasses only for the following question. All construction lines and arcs must be clearly shown. Construct triangle ABC in which BC is 6.5 centimeter, angle ABC is 60 degrees and AB is 5 centimeters. Construct the locus of points at a distance 3.5 centimeter from A. Construct locus of points equidistant from AC and BC. Mark 2 points X and Y which are at a distance of 3.5 centimeter from A and also equidistant from AC and BC, and measure XY. Now out here, there are two loci here. Can you see these two loci? Now if the point is 3.5 centimeter from A, as we had done in what is locus part 1, if a point is equidistant from a fixed point, its locus will be the circumference of the circle with A as the fixed point, the center, and 3.5 centimeter as the radius, right? Okay, so we'll have to construct a circle here and construct the locus of point equidistant from AC and BC. The common point is C, which means these two line segments are intersecting at C. And so angle C is to be bisected and the locus of this point will be the angular bisector of angle C. So we have two loci here and then X and Y will be satisfying both of these conditions, which means these two will be lying on the two loci, which means it will be the point of intersection of the two loci. Okay, so let us see how we do it. I'm going to construct triangle ABC because this is too simple, you will know. Then I will construct this for you. The locus of a point 3.5 centimeter from A will be keeping A as the center and drawing this circle, and it will be the circumference of the circle with A as the center and 3.5 as the radius. So from here to here is 3.5 centimeter and that is the radius. Okay, now locus of a point equidistant from AC and BC. AC is here, BC is here. So which is the common angle? Here. So it will be angular bisector of this common angle. So let us see how we draw the angular bisector. All of you know how to construct the angular bisector, right? I'll just make this slightly darker. Okay, so that you'll be able to see. Now, this is the point which is the point of intersection of the two arcs, and then we join it to C. And so this is the locus. Now, what does our question say? Mark 2 points X and Y which are 3.5 centimeter from A as well as equidistant from AC and BC will mean that they are the intersections of the circumference of the circle and this angular bisector. So we will call this point as X because this is where the circumference and the angular bisector will be intersecting, and this will be our point Y because that also is the intersection of the two loci. Okay, and now they are telling us to measure XY. So let us see how much is XY. It's 5. I'm getting it as 5 centimeter. So let us write this XY equal to 5 centimeter. Now be very careful when we are writing these measures because your marks depend on this. Now this again is a 4-mark question, and now you see how the locus constructions are incorporated with your triangle constructions. Now I'm going to make another video where you will learn how to construct the circumcircle and the incircle for various triangles. But as of now, this is where we'll end this video. Thank you for watching. Don't forget to like, share, comment and subscribe.